Okay, now, what does the midpoint tell you? Half of what? Half of 360. So take the 360 miles. So take the 360 miles, divide that by 2, and that's going to give you 180. So that tells me, and that should tell you, that from here it's 180 miles, and from here it's 180 miles. Now, the question says, how much farther do they have to drive before they stop for lunch? Well, if they're stopping for lunch right here, and they've already traveled 55, and they know that they have to travel a total of 180, how are we going to figure out? Subtract what?
Minus 55 from 180.
180 minus that 55 miles. That's a 17, that's a 5, that's a 12. We got to travel another 125 miles. Now, the first time through, results were kind of poor on that question. And I think it had to do with the fact that you didn't really do anything with the midpoint. Or if you did, I've also saw that when people came up with 180 miles, they just said, all right, it's 180 miles that they have to travel yet. But they've already traveled that 55 miles. So you got to read the question thoroughly. You got to make sure that everything is going on the way that you need to go on with that. Now, number 3. JL is a segment here. Now, do we have a picture for JL? No, draw JL. And it says K is the midpoint. So I'll put K here, and I know that these two segments are going to be equal to each other. How much is JK? 6x. How much is KL? Now, remember, geometry is a visual. It's a visual discipline. So you need to draw pictures, and you need to label pictures, and you need to do everything with that. Now, in this case, I know this is the midpoint. What's the relationship between JK and KL? They're equal to each other. So that guy and that guy are the same. So JK is equal to KL. So now how do we set this up? What do you mean the other way around? Well, the equation? Yeah, that's fine. If you would have put 3x plus 3 is equal to 6x, that's fine. That's the same thing. Now, how do you solve this for x? Say that one more time? Yeah. Subtract 3x from both sides. (3x) is equal to 3. So x is equal to what? 1. So now we could go back up to here, or we could just say JK, which is equal to 6x, is equal to 6 times 1, which is 6. So I know this value is 6. So what would this value be? 6. And the whole thing is 6 plus 6, which is 12. So this is a good combination of both. You could use this one used the midpoint formula, the idea of the midpoint formula, and what a midpoint actually is, but also it used the segment addition postulate. So it used both of them at the same time. This is a good question. All right, now try number 4. I'll give you a minute. So, all right, ladies and gentlemen. First thing that you should always do when you have a diagram like this is label the diagram. So it says the measure of angle IJK. There's IJK is 57 degrees. So which angle is that? The whole thing. And if I were you, what I would do is I would put an arc here and maybe put an arrow and say that's 57 degrees. Because it's really hard to label the big angle when you have the two smaller angles that are cut up here. Now it says the measure of angle IJL is 20 degrees. IJL is 20 degrees, so put the 20 degrees here. And it says we want to find the measure of LJK, which is this value here. Now, what's the segment addition statement from this? And I'll give you a hint. It's the measure of an angle plus the measure of another angle is equal to the measure of a third angle. No, we're just going with the names of the angles first for the angle addition postulate. So the first angle here would be angle IJL, because that would be this angle right here. Now we got to go for a second angle. What's the second angle? LJK. And that's fine. But for this, we could say angle LJK, and that's equal to what angle? IJK. Alright, now what do we know is the measure of angle IJL? 20 degrees plus x should be equal to 57 degrees. Alright, subtract 20. X is equal to 37 degrees. Yes? Well, that's what we are going to end up doing. The problem is, once we get into more complicated situations, I have noticed that if this statement isn't there, things start to fall apart. And if that was an expression, that was an expression, and this whole thing was an expression, for some reason, if it's just not numbers, students have a lot of problems putting together the angle addition postulate. So this statement is actually a really, really important thing. And if I give you guys a quiz on that, I'll ask you what the segment addition statement would be. So this would actually be a point. So I know that you guys know how to make up the sum of the parts is equal to the whole thing. If you guys were all experts and mathematicians and all that, I would probably not even worry about it. But we're not there yet. All right, let's look at the back. Yeah, you can. Take a look at your paper. You can read the paper. It says ray NP bisects angle MNQ. So what do we know if this bisects something? What does bisects tell us? It cuts the angle into how many parts? 2, but what do we know about those 2 parts? They're equal to each other. When you bisect something, you cut it into equal parts. So I know that this angle is equal to this angle. Now, MNP from right here is 6x minus 12. So 6x minus 12. And PNQ right here is 4x plus 8. 4x plus 8. So what do I know about these 2 parts? What do I know about those 2? What was that? Not necessarily the equals to a sum because we don't know what the total value is. But what we do know is that they're equal to each other. And that comes from the idea that when you bisect the angles, you cut them into 2 equal parts. So we get 6x minus 12 is equal to 4x plus 8. So how do we solve this? Subtract 4x from both sides. 2x minus 12 is equal to So we get 2x is equal to 20. Divide by 2. X is equal to 10. But is that what the question is asking? The question says find the measure of angle M and Q. Now for the first angle, 6x minus 12, plug in the 10 value. So that's 60 minus 12, which is equal to 48 degrees. So this guy's 48 degrees. What do you know about this angle then? It's not vertical, but they're equal to each other. So it's 48 degrees. Now, obviously it's not drawn to scale, and when you're just drawing an angle, it's not drawn to scale. If I asked you to redraw it, once you figured out what the values are, then you would take your compass and protractor and draw the angle out as much as you can. But the big thing you need to take away from here is, again, that word bisects. And I'm sorry that it's a little bit blurry, but it bisects those angles, 48 degrees, 48 degrees. And that's what we ended up with there. Ended up with a 96 degree angle. Yeah. So your question is, do you have to show work when you're doing a math problem?
No, I'm saying like
No. That's what your question boils down to. Do you have to show your work on a math problem in a math class? But that's what your question is. Yes, you have to show the work. You cannot just put down an answer. You cannot just go there. You have to show all the work.
But you didn't do it on here.
I showed work on here.
I'm saying for both sides. But I have to replace.
Well, I didn't need to because I know that bisecting cuts it in half. But you need to show your work, and I showed the work.
Yeah, but if you know that both sides are equal, do you have to do the same thing to show work?
Well, that's part of the work.
You know they're equal.
But that's part of the work, so you're okay. But the idea is you have to show all your work all the time. And in this case, because we know bisects cuts into 2 equal parts, and you have to be able to explain it. If I come up to you and say, well, if you just said, all right, I know since that guy's 48, I know this one's 48, and I said, well, why? You need to be able to explain why. If you can explain why, that's good.